When we are referring to the weather as being dry or humid, we are simply specifying the amount of water vapor content found in the atmosphere. So the amount of water vapor in the air determines the humidity of that air. So water vapor is simply liquid molecules that have evaporated and become gas molecules. So let's suppose we have the following closed container. So our system of gas is composed of three different types of gas molecules. So we have the blue, the orange, and the red gas molecules. Now, the total pressure inside our gaseous system is simply equal to the sum of the individual pressures due to the different molecules. So P1 is simply the pressure due to the blue molecules, P2 is simply the pressure due to the red molecules, and P3 is simply the pressure due to the orange molecules. And we call these individual pressures partial pressures. So the partial pressure is the pressure that the gas molecules would exert if they were alone inside that container. So we define something known as relative humidity as the ratio of the partial pressure of the water vapor to the saturated water pressure at that specific temperature. So the relative humidity is given by the following equation. So we take the ratio of the partial pressure of the water vapor to the saturated water vapor pressure of water and multiply that by 100%. So we take the fraction and multiply it by 100 to convert it from fraction to percentage. So the saturated vapor pressure of water is simply how much water the atmosphere or the air can hold at that specific temperature. So, let's look at the following example. On a particular day in New York City, the temperature is 25 degrees Celsius. Now, if the partial pressure of H2O is 22 torrs, what is the relative humidity? So we need to determine the saturated vapor pressure of water at 25 degrees Celsius. And we could simply find that online or in a textbook. So let's assume that at 25 degrees Celsius, the amount of water that can be held in the air is given by the following pressure, 23.8 torrs. So to find the relative humidity, we simply take the fraction of 22 torrs divided by 23.8 torrs. The torrs cancel. We take this and multiply it by 100%, and we find that our relative humidity of the air under these conditions is 92.4%. Now, let's explore one important biological implication of humidity and vapor pressure. So, the human body cools itself through the process known as evaporation. So, it evaporates the moisture found on the skin, and that cools our bodies. So at very high humidity, this reduces the process and creates very uncomfortable conditions. So if the air is completely saturated with water, then the water found on our skin will not evaporate because the atmosphere will not be able to hold any more water molecules. And this will create uncomfortable and sometimes dangerous conditions because our bodies will not be able to cool itself via the process of evaporation.